Okay, I guess we'll get started. It's a surprisingly small turnout today. Anything going on? Okay, so today's topic is how to design a good usability evaluation, which is the next homework that you're going to start. So hopefully everybody got their grades back from homework 1. And some people have had trouble. The graded version of your PDF should be there as well with lots of comments. So let me know if you can't find it. Homework 2 was due today. The late policy still applies for homework 2, but I found from previous experience that if you let the homeworks get away from you, then it's really hard to catch up. So you're supposed to start on homework 3. Now, because of Thanksgiving next week, homework 3 is actually due on Monday, so you only have 5 days to do it. So that's something to keep in mind. And it does have 2 steps, so it's not something you can really do at the last minute. And just as a quick summary, this is a user study, kind of in the same way that homework 1 was a user study, but we're teaching a totally different way of representing your answers. So you won't be using diagrams this time. Instead, there's a template that I'll show you in a minute that is where you're supposed to enter your answers. People are always interested in how they did with respect to the rest of the class. So this is everybody's grades. About 66 people turned things in. About half of you got A's. Somebody got some extra points for doing extra diagrams, maybe a physical diagram. And the low grade was a 70. And the TA said that the people who got low grades primarily didn't read the instructions and skipped parts altogether, or they didn't look at the textbook or lectures and didn't understand the diagrams. If you didn't really understand how to do the homework and you're down in this section, I recommend that you check and see what you did and try and understand it better, because contextual inquiry is also on the final exam. And there's still a bunch of people who haven't turned in homework 1. Hopefully you're going to do that today, or have already done it, because obviously it gets to be less and less worthwhile. Okay. So today's topic is doing user studies, and just to quickly switch over to the website. So what you're going to do on this homework is you're going to take your prototype that you just made and do a user study on the prototype. And you remember we saw this video last time of the German guy doing a usability analysis with the paper prototype. So it's going to kind of look like that. So you're going to do that for part A. You're going to try one user on your user interface, and then you get to try and fix your user interface based on any problems you discover, right? And presumably the user will find some things hard to do. If not, maybe you didn't have enough part of your task or whatever. So you're supposed to fix a few things and then run a second user. So that's why I was saying this is kind of like 2 phases. You can't really do it all at once. You need to try a user, fix up a few things in your prototype, and then try another user. And there's a pretty simple template that we'll talk about in detail later, where you will fill in your answers. And the main part is this table, where you're going to talk about issues that you saw. So instead of doing diagrams, you're just going to put all the issues into this big table. It's pretty straightforward, but we'll talk about the pieces of it later. And again, this is due next Monday, before you go on the holiday. And there's no class next Wednesday, obviously, because that's a school holiday. Okay, so why is it important to do usability evaluations? So one would hope that by doing a contextual inquiry and understanding your users really well and then following guidelines, you could produce a good user interface, and obviously those help. But unfortunately, it's not ever sufficient in order to produce a good design. Another thought is, oh, we're just going to hire some really good designers, and therefore we can skip this step. And that doesn't work either. Good designers obviously do a better job than bad designers. So, hopefully if you get some good designers, you'll start off in a better place than you will with average designers or bad designers. But studies show that even the best designers are going to miss things. They're going to have some of these blind spots that we talked about in the first lecture. They're going to do things that seem reasonable to them that users get confused by. So every design is improved by using usability studies, even those by good designers. And if you're an average designer, how high you can get this dot compared to if you had a good designer, obviously that depends on lots of different things. But in every case, usability evaluations are really important. If you remember when we talked about contextual inquiry, we talked about it in terms of participation, in terms of collaboration, and we use kind of the same language when we're talking about these usability studies. We tend to want to call the people participants. Subjects makes it sound like you're doing an experiment on them, right? They're lab rats or something. But we really wanted to give more of the idea that they're participating in helping you improve the user interface. And users is also kind of maybe misleading in the sense that they may or may not be actual users of your system. So the usability evaluation is not the same as QA testing, quality assurance testing. Obviously, you want to do quality assurance testing, and you also may end up discovering bugs in your user interface, actual things that don't work as a result of usability testing, and you should certainly make a note of those, but it's not the point, right? If you're doing QA testing, you really have to go through the whole interface and try all sorts of bizarre things. In usability testing, you want to have people try out the more typical things. It also doesn't help to have people on your team evaluate it. That doesn't count as a usability test. And it's also not sufficient just to ask the users questions, to ask the participants questions. I've been to a bunch of companies where the salesman would say, oh, we do all sorts of user testing. I go and demo the product to the customers and ask them what they think, and they always say it's great. And so therefore we do user testing, and that doesn't count at all, right? It's not sufficient to demo the system to people, and it's not sufficient to ask their opinions about stuff. Just like with contextual inquiry, you want to see what they actually do. You want to make sure that they can do things correctly with your interface. And it's also better to do things in a realistic way, which means individually. So focus groups are not the same as doing a usability evaluation. So you shouldn't give the interface to a whole group of people and say, let's play with this and get the group's opinion. And like we said a bunch of times, it's important that the users come in with the same kind of knowledge that they would if they were using the product for real. So if you train the users on how to use your system, then that's really not realistic, because in the real world, people won't have that kind of training. So the trick is to get them to do what is useful without giving away too much of the information. And we've said this a bunch of times, that it's important to tell the participants that we're not testing them, that we're testing the system. And so you want to say things like, that's another reason not to call it a user test, because you're not testing the user. And another problem is that if you are the designer as well as the experimenter, then you've just designed this thing, you think it's really good, and this user is going to fail to do stuff. And so that tends to be kind of a conflict of interest for you personally, in that you really like your design, and now what are you going to do about this problem that people are having with it? So it's really tricky, but it's important as a designer to try to, like it says, put away the fact that you're designed this and try to be more objective. A question that the management team and maybe the engineers was going to ask you is, why should I trust your results? I don't really believe that this is a reliable results that you got. Our real users aren't going to have those problems that you identified. And some of the reasons that this happens is that there's enormous individual differences, especially in skill-based tasks like programming or using user interfaces. And hopefully you saw that to some extent in the contextual inquiry when you tried somebody who was not a bit like you. And some people have measured there's this difference of up to a factor of 10. Some people can do things 10 times faster than other people, which is really dramatic difference in time. If you're trying to do something statistically significant, which we won't talk about much in this course, there are statistical ways of measuring whether it's reliable or not, but usually that's really not what we're worrying about. And of course, if you have a great big website, or if you have a camera with 50 screens, you probably aren't going to be able to get through that entire interface with a single person in a usability test. So you can't say anything about parts of the interface you haven't tested. And there's also threats to validity. So validity means whether the actual results you got are meaningful at all. And some of these can actually be real problems. So one is if you have users that aren't representative of your target users. So if you have really smart test users, like if you're a company that's really paranoid, and so you're not willing to show any external people what your interface is like, and the only people you can find are engineers, so you test them as your user base, but your actual customers are nothing like engineers, obviously that's not going to be very helpful. And then there's confounding factors, which means something else that interferes with the results that you were hoping to get. And these end up being you have a set of tasks. It could be that the earlier tasks tended to give away the answers to the later tasks. And so therefore, the later tasks aren't really valid anymore. It could be that there's this thing that makes your system unusable that's really not relevant to your test. So when my students are inventing new interaction techniques or we're inventing new interfaces, they never implement the whole thing, right? So undo is really hard to implement, so that's usually not implemented. And copy and paste is never part of the interface, but it's kind of something everybody expects to happen. So if your system doesn't have some of these things just because you haven't gotten around to it yet, sometimes those will turn out to be barriers to testing what you really care about. And so then you'll end up with this issue that there are these confounding factors of something you don't care about is getting in the way of testing what you do care about. Learning effects means that they've learned something either from your instructions or from the interface that is not what the real people would have learned. And so that is another one. And then, of course, if you help people a lot as the experimenter, then that's not very valid either. So it's important to plan out what you're going to do in advance and not just wing it. And there's a variety of aspects of this planning. The first thing is to decide kind of where you are in the process and what you're trying to achieve. So are you trying to do formative evaluation, which means helping to understand the features, helping to understand how your competitors or the previous version did? And so that's kind of what we did with the contextual inquiries. As opposed to summative evaluation, where you have something that you've designed and you're trying to test it out. And that's kind of what the key focus of today is. After you've designed your pilots and you've designed your instruction materials and you have the system you're ready to test, it's always a good idea to do pilots first. Pretty much 100% of the time, you'll discover some problem with your setup. Usually it turns out your instructions are not very clear and people are confused about what they're supposed to do. And it also, sometimes you can find these confounding factors that oh, I really have to add cut and paste into this interface or else we'll never get anywhere. And so you can do these pilot evaluations on your friends, on other people who would not necessarily be valid subjects. And so you really don't want to waste a valuable subject. If you can only find a few subjects, you really don't want to waste them. So you want to kind of do a few internal people first, or people who are cheap but maybe not at all relevant. And typically you throw away the data from the pilot studies. If the pilot studies go really well, that really doesn't tell you much about your product. But if it goes poorly, then that tells you a lot about what you need to fix before you even bring it to the real subjects. Also, when you're trying to recruit people, they want to know how much time they're focusing on this. And hopefully you had the experience that you had to guess how much content you needed and how long it was going to take people in the contextual inquiry, but that kind of thing is really hard to guess. And so it's useful to do some pilots to kind of see where you are in terms of time. If you have two different versions of something that you're trying to test, there's basically two ways to design that kind of study. One is called between subjects and the other is within subjects. So within means each person sees both versions. So you show version 1 to the user, and then you show version 2 to the user. And obviously, if that's a really good user or a really poor user, they'll presumably behave about the same way on both ones. So that removes the individual differences. The problem is it adds in this issue of ordering effects. So especially if it's a problem-solving task, how would you find this product on my web page? We have two different versions of the web page. Try and find it on version 1. They're going to see all sorts of names as they go through it, and they're going to search, and they're going to find stuff. Then when they look at version 2, some of that learning about how it worked in version 1 is going to transfer over, and people almost always do better on the second time. Right? So if you show everybody A first and then B second, B is going to be the clear winner, independent of how well it was designed, just because people learned how to do it. The only exception to that is if you have performance tasks like typing, right? So if you had two kinds of keyboards, or I guess that would still have learning effects, or flicking. There's some kind of tasks where it's really so mechanical that you don't learn anything from the first one. Yeah.
So in the studies, would they then switch the order?
Right. So that's a typical way to help with that. Is some people get A first and some people get B first. But we've also had tasks that are so hard to design A and B that are different enough that just doing A always gives away the answer to B. Like if you're trying to find something and they don't necessarily know what it's called, once they figure out what it's called, they can't figure out what it's called again because they already know the answer to that. And so sometimes it's really tricky. Ideally, A and B would be about the same difficulty, the tasks you give, or it would be the identical task, but it's typically impossible to give the identical task twice for lots of different kinds of tasks. So that's a real challenge with within. And so sometimes it's a lot easier to do between, which means you only have to design one version of the tasks. Half the people get A and half the people get B. And then the problem is, well, you need twice as many people because in order to have the same amount of validity in terms of how many people use each one. It's also faster for each user, so within takes about twice as long as between. So if you have a 1-hour task, then within is going to take people 2 hours, and that's kind of getting beyond what most people are willing to do. And you also have the problem with between that some of your users are smarter than other users, and so the trick is to how would you balance that? And there are all sorts of kind of hidden confounds with designing these kinds of things. So for example, if you put everybody who shows up early on the new version and everybody who shows up late on the old version, it might be that all the people who signed up first were your eager ones. Or it might be they're the ones who have nothing better to do, right? And so a more valid way to do it is actually to randomize each person into which category they go, whether they get A or B. So then it doesn't matter whether they're early or late or whatever. And also, it's more valid to randomize the order that people get stuff in rather than having it fixed. So what can you measure during these kinds of user tests? And so a lot of these are different than just pure usability, or just kind of, are there bugs in things? So in the CIs and in the study we're going to do now, we're mainly focused on usability barriers. But there's a lot of other things you probably care about. And so these are all important. Learnability says, given a brand new person who's never tried this before, can they figure out how to do stuff? Right? And you can measure that. So another advantage of these things is you can actually come up with numbers that represent these values as you do your user study, your usability evaluation. So for learnability, you could count the number of times that they have to look at the help system, or count the duration of time it takes from when they start to where they succeed at each task, right? Or you can measure how many tasks they succeed in doing. So all of these can be measures of learnability. You might also be interested in efficiency for experts or for people who are no longer novices. And then obviously the measures are things like the time to complete tasks, the number of tasks you can do in a fixed amount of time, the number of tasks you can do correctly. For some tasks, you can measure the quality of the tasks, of the results. So if they're trying to do something and it's some sort of creative task, then you may have a measure of quality. Errors is another important thing to measure. Error rates is how many times people make an error during a task, or how often they come up with an error, how much time is spent recovering from errors or making errors, the error severity that people, do they get stuck as a result of these errors, or are they just kind of annoyances they move quickly beyond? Of course, there are lots of other measures you can get from web analytics, time on page, click-through, links, all sorts of abandonment rates, completion rates, click-throughs, and so forth. And then finally, even subjective satisfaction can be given a number. You can use some standardized questionnaires, and you could use the same questionnaire on, say, people using the current version of your product or people using your competitor's product. And then you could use the same questionnaire on your new version and see if you get higher scores, see if people like it better. And that way you can actually come up with a number about to what extent you're improving. So the advantage of having these numbers is that you can get objective, quantifiable measures that you can bring to your management or whatever to tell how you're doing. Are you really getting towards an improved version? Are you succeeding in providing benefit for all this engineering effort you're proposing? And that's why sometimes this is called usability engineering, right? So the idea is to try and convince the software engineers and your management and other people who are used to dealing with numbers, to convince them that you can actually have numbers for usability and that you can use those numbers as a way of measuring your progress, knowing when you're done, telling how much you're improving. It's also really useful to instrument the software. Just like you can have web analytics, you can actually put similar logs into desktop or smartphone products. And so you can either secretly or transparently log what people are doing, keep track of how many errors they have and things like that. Turns out to be really useful. So another way to make this more like engineering is to pick actual target values, right? So the Nielsen textbook recommends these kinds of measures. So you can measure how many errors people are making currently. And obviously the best for errors is 0. where are you trying to get to with this product? And maybe you're trying to get to 0, but maybe it's perfectly reasonable if you only have 1 error per hour or whatever. And maybe that's hard, so maybe there's another level where you can decide it's okay to stop. And so you can kind of come up with these numbers based on your current system, based on the goals from your marketing team or whatever in terms of this particular product. And you can do this for all the things we talked about before. So time on task or time to complete tasks, obviously 0 doesn't make any sense. What is the fastest time to complete this task? It's probably how fast you can do it, right? And so you measure an expert, one of the designers, okay, well, he can do this task in 3 minutes. So that'll be over here as best. And in our current product, it takes 20 minutes to do this task. And we really think we can get down to 5. And if we get to 10, that's half the time, so that's good enough. So you can come up with these kinds of numbers as part of your budgeting and planning process. Questionnaires. So you guys kind of came up with interview questions, which is kind of a questionnaire. It turns out questionnaires are really hard to design. There are whole subjects, whole classes on this. You'll want to get things like demographics. That's pretty easy. But you also kind of want to understand their feelings towards the previous version, towards what they're seeing as you're showing them things, and to try and measure these kinds of things which you can't necessarily observe. And often, if you end up with questions that people don't understand, that will result in data that's pretty useless, that they might not be answering what you were hoping. So one good way to design questions is to use the Likert scale or the semantic differential scale. Both of those are very, usually pretty clear. And the idea of that is that you propose something and let people agree or disagree. Like, the system was easy to use. Agree, 1, 2, 3, 4, 5, disagree. Right? And so typically you'll have a reasonable number of numbers there. 10 is kind of the maximum that ever makes sense. Often people want to have, you can decide whether you want to have an even or an odd number, because sometimes people like to be right in the middle. I have no opinion, or I don't really care, right? So an odd number means there is a middle value, but an even number means there's no middle value, which requires people to be on one side or the other. A semantic differential scale uses opposites, and this is a little trickier because people may not feel that what you picked are actually opposites. But here's an example. Finding the right information was difficult to easy. And here I've made difficult negative numbers and easy positive numbers. But you can number these whatever way makes sense. And of course, you can have people rank order things. There's a variety of choices. So, pretty much said this already. One of the things people often wonder about is if you're using these kind of scales, it's important that all the good answers line up. Or say, and you should phrase all your questions so that if the user is really, really happy, then there's kind of a column of answers. And if the user is really unhappy, there's a column of answers, rather than having to zigzag, right? So if I said, the system was easy to use, agree to disagree, the documentation was confusing, agree to disagree, right? Well, then they're supposed to switch to the other side and disagree that the stuff was confusing. And what tends to happen is people don't read too carefully, and they say, after they read the first one, it's like, yeah, I really love this, and they'll just circle all the answers on the same side without reading carefully enough to notice that they're supposed to go back and forth. And actually, people did studies of this, and this is a reference that shows that if you alternate, people do get confused and you get invalid answers, because now you don't know whether people, it seemed like this person was really happy, but then they told me that, this part of the interface was, absolutely terrible, and maybe it's just because they were confused in the answers. And Here's an example from a study we just now designed a couple weeks ago. And it was a good thing we ran pilot subjects because we discovered our questions were confusing. One of the questions was, how big is the code base for this project? And these were the answers from the pilot studies. 300, 50,000 SLOC, 34,000, 342,658, 2,000 files, and big, right? So there's nothing we could really do with that data. First of all, the 300, we have no idea whether that was 300 lines or 300,000 lines. What was the units they were thinking in their head? I don't know what SLOC means as opposed to regular LOC. LOC is lines of code. 34, I mean, this number is so specific. We don't know if he was just being sarcastic because there was no way he could possibly know, and so he was giving this sarcastic number, or he actually had some tool that could measure that. So we ended up saying, and 2,000 files, there was no way to deal with that because the files could be, 20 characters or 30,000 characters. So we said, okay, that's never going to work. So we had to revise our question in ranges because we really didn't care the actual numbers. We really wanted to know if this is a little program or a big program. So then we said things like up to 1,000, 1,000 to 10,000. So we kind of did this orders of magnitude thing. And that way everybody understood what we were talking about and could give more clear answers. If you don't want to bother authoring your own questionnaire, then there are some standards out there that you can just use. And an older one is called the Questionnaire for User Interface Satisfaction, or QUIS. And this is available, if you're a company, you're supposed to license it and pay a little bit of money, but you can download it for free. It's a little long. It has 16 pages of questions, which is a little excessive for most studies. But it really does get at every possible feeling about the interface in terms of what people felt about it. And then this is a shorter one, which is much more usable. It's only 10 questions. And this is an example from the textbook, really focusing on, the different levels. And you'll notice that the bad stuff is on the left and the good stuff is on the right. Right? So it does have this, and it's a semantic differential scale, which means there's bad to good on each one. Here's some more. Okay, so let's go back to the user studies. Again, we're recommending that you videotape them, especially since you're going to be doing these solo. It's really hard to keep track of things. Hopefully you don't have to use the videos much in real life, but it turns out they're also really useful, as I mentioned before, about motivating people, taking excerpts out of your user studies and showing the engineers, look, you designed this part really badly. Look at this user failing to succeed at it. Maybe we should fix that. Also, we found it really important for impact analysis. Sometimes people come back and say, well, really, how important is this? And you'll say, well, I guess I could measure that. And then you can go back to the videotape and say, look, on average, users wasted 3 minutes on this particular feature. And the range was 1 minute to 4 minutes. And we really think that that's an unacceptable amount of time to be wasting on this one feature. And so if you get these follow-on questions, then otherwise you'd just be totally lost and you couldn't do anything about it. But if you have the videotapes, you can always go back and do further analysis. So what we're talking about in this assignment is the Think Aloud protocol. And Nielsen says it's the single most valuable usability engineering method. It involves getting people to tell you what's going on while they're trying to use your interface. And one of the key advantages is you learn why things are happening. So this why is really hard to get any other way. Right? So they click on something and you're wondering, I wonder why they clicked on that. Well, just ask them and get them to tell you why they clicked on things. One issue is if you're trying to time how long things go, then a Think Aloud protocol kind of interferes with that because the users can't operate at full speed because you keep interrupting them. And so if you really care about timing, then you kind of can't ask what's going on. But usually it's more important to understand what's going on than it is to have very exact timings of how long things take. Most users aren't very good at this. I know in your CIs, did you have to encourage people to keep talking? Or did people just say stuff? Yeah. So it's really important to get people to tell you what's going on in their head. Sometimes they just think it's obvious, and sometimes they just don't feel like explaining. But you can ask general questions that hopefully will get at what they're thinking without interrupting their flow or giving away the answers. And the trick is not to give away any of the answers with the questions. So if you say, what do you think this button is for, or why didn't you click here, then that shows them what to look at. That focuses their attention on the thing that is relevant, and so that's really not appropriate. If you really can't get people to talk for any reason, then sometimes it works to have two people together and to have them talk to each other. This works especially well with little kids. So if you're doing an interface for kids, they love to talk to each other, and so that works out really well. Or if you happen to be doing something for collaborative. So for your user studies, you really want representative users. If your product is really broad, then you might need representative users of different groups. Sometimes it's tricky to get users in your customer companies. So if you're a company to company, B2B kind of situation or website or product, then typically you're going to want to go to your customers and ask for if you could try out your product on some of your real customers. If you ask a manager, who are they going to give you? They might give you their best people because they will think that that'll reflect well on their company. They might give you their worst people because they don't really care if they miss time, right? But what you kind of would really love is the most average person. And, it's really unlikely that that would be the person the manager would pick. If you ask a manager, can you give me a person to try out this new version? Generally, we found that companies are delighted to participate in usability studies. Because basically you're saying to this company, we're going to try and improve our product so your people work better. We're going to try and make it more useful for your people. And who would turn that down, right? So you're going to customize your product to make the people at this company more effective, to save them money, to make them work better specifically for their problems. And so that's usually a big driver, a big advantage to people, and they would often be delighted to help you with that. Sometimes you have to pay people, especially if you're trying to get people off the street, to do something really long and onerous. And companies like Microsoft have a very standard mechanism for this. They give people coupons for stuff from Xbox Store or from the Microsoft Store, or they have little trinkets or whatever. It's tricky to pay highly skilled users. Like if you're trying to test a product on doctors, giving them $10 is just insulting because they make more than that, in the few seconds that it would take you just to say hello. But giving them a little gift somehow seems totally different, right? And so, if you give them a mouse or, a CMU mug or something that's, has a logo on it or has some unique kind of, property, then that's kind of more often better than just trying to give people money. And you have to decide for your user study whether you want to test novices or experts. And you may want to do both, but it's certainly part of the strategic design. How many do you need? Typically, when you're doing studies for statistical analysis, you need at least 10 per group. But it turns out if you're doing this kind of usability evaluation that we're talking about, where you're looking for problems, you can get almost all the data you need with as few as 5 users. So it's kind of like this this graph. So if you don't do any users, you won't find any of the problems. But even with your first person, you're finding about a quarter of the real problems in the system. So you're getting an enormous benefit from that first person. With the second person, you're getting up to about 35%. And by the third person, you're getting 70%. But by the sixth person, maybe you're getting 80, 90%, but then you're getting less and less help from each subsequent person because they keep finding the same problems all over and over again, right? And so there's really no point in going from 12 to 15 because you're going to be wasting most of your time with people telling you stuff you already know. And so one alternative to this is after every user study, you try and fix the things that user identified. And so that's kind of what we're going to do in the homework, is that hopefully you can fix things. Now, the problem with trying to fix things is you may actually not fix it. You may make it worse. You may make something else worse by fixing this thing. And so you still have to keep doing this iterative testing to make sure that it's always improving. There are some ethical issues with respect to doing user testing, and this is true of any kind of testing with people or animals, it turns out. And you might think that this is silly, it just has to do with drugs. So if anybody's ever been in a trial of a drug, there's all sorts of rules about whether you get the placebo or get the real version, and what they're allowed to do and what they have to tell you about. And it's kind of the same thing for these kind of psychology or human factor studies, mainly because of emotional distress. Highly trained people aren't used to failing at stuff. And when you do user studies, hopefully you're going to find things that don't work. And so there's the potential for making people feel really bad. There's even the potential for affecting people's jobs. So if you ignore all of these kinds of issues and you go to a company and ask the manager to give you a guy, and he does, and he tries your experiment, and then you go back to the manager and say, that guy was terrible. I don't know why you even hired him anymore. You should fire him. Obviously, that's going to have a negative impact on that guy's career as a result of him participating in your study. So one of the primary requirements is that all the data is anonymous. And we're going to emphasize that in this experiment, that you have to make sure that nobody finds out which individuals provided which answers. In order to make the person feel better about it, you want to emphasize again that the system's being tested and not the user. There's some great videos on the web about people actually breaking down in tears because they were so frustrated and unhappy at the systems they were trying to use. And to the extent that they understand that you actually are hoping they'll find some problems for you so you can fix them, that would help alleviate some of this anxiety that people will feel about failing. You should certainly stop the evaluation if the user's upset. If you have any deceptions, you're supposed to explain them at the end. Sometimes you'll tell people you're testing one thing when you're really testing something else. Because if you told them what you're testing, they would focus too much on it. So that's often, it's not unreasonable to have deception or misleading instructions as long as they're explained at the end. And at universities, we have what's called the Institutional Review Board, IRB, which reviews all of our studies. Has anybody done a study at CMU? No? Okay. So if you do a study here, and my group does lots and lots of studies, there's an official board over in Warner Hall where we submit the study we're planning to do and what's called the consent form, which is what people sign to say, yeah, I'm fine with participating in this. And they approve it or they recommend changes. And we're not allowed to do any studies until we have approval. And one of the reasons for that is the Milgram psychological studies from the early 60s. Any people familiar with this? Just a couple. So Stanley Milgram was a psychologist, and he did this very famous study he was wondering why so many Germans were willing to go along with the Third Reich, and why so many people just did these awful things that they knew were awful because someone told them to. And he thought that maybe it was something to do with the German culture, or people were scared. And so he designed this experiment to see what it was about telling people to do something. So in the experiment, the subject, or the participant, was the teacher, and he was told by an experimenter to shock the learner whenever the learner got an answer wrong. And so it turned out that the learner was actually an actor. He wasn't actually getting shocked, but he was trained to get things wrong, and then to moan and cry and stuff like that as the shocks got higher and higher. And what the experiment showed, and there were lots of different conditions, whether they could see the learner or whether they couldn't see the learner, whether they could hear the learner or not, how much the learner cried out. And in some experiments, the learner cried louder and louder and then went completely silent, right? And in that case, the teacher still couldn't see them. And so the experimenter typically would say things like, "You must continue, please continue." And the teacher would say things like, "Oh, I don't want to go any further." And the experimenter would say, "No, it's part of the experiment, keep going." And 65% of the subjects were willing to give apparently harmful electronic shocks to pitifully protesting victim. So this was a really dramatic experiment that showed that people really were willing to follow instructions, even when they knew it was hurting somebody. And the problem was that all of the people who participated, all the teachers, were emotionally distressed as a result of participating in this experiment. They had nightmares. It affected their life afterwards. Some had emotional problems that this triggered. And so this particular experiment, even though there was no medicines, it was all a regular old psychology experiment, actually had dramatically negative impacts on all the subjects. And so this is kind of an extreme example just to show that it's not that, even though what we're doing is user studies, and you're probably not going to shock people if they get the wrong answers, you still have the potential of hurting people emotionally. Yeah.
So were the teachers informed at the end that there were actors on the other side?
Yeah, I don't remember the answer to that.
Yeah.
They were? Yeah. Yeah, and even that, people were just so upset at what they personally were willing to do. This revealed something about people that they really didn't want to know, that they were willing to go to this level if somebody told them to.
They've done several repeats.
Huh?
They've done several repeats.
Yeah. And so there's if you go to Wikipedia or this website, there's lots of information about this experiment and repeats and so forth. But nowadays, you can't really get away with, doing this kind of experiment without a lot of, different design. Okay, so now you have to set up your design. You need to set up a realistic situation, write up the task scenarios. Again, you have to write up a detailed script of what you're going to say, which is part of the homework. And you'll need to recruit some users. It's important to practice, and that's another good reason to have pilot studies. Obviously not so much for the homework, but for real life situations. You can practice asking the questions, making sure the system works appropriately. This is the same script that was in the previous lecture, where you ask some questions and then you give them instructions. In this class, obviously, each of you gets practice running experiments. But there are actually people who have formal training in doing this kind of thing, and so they might go under the title of facilitators. But pretty much any usability specialist will have a lot of practice at doing this. And as you saw when we did the video in class, that a trained facilitator is much more likely to discover interesting things than somebody who's not that experienced. And there was actually a study done where they gave the same system and the same user study to software engineers versus usability specialists. And the usability specialist found about twice as many or 3 times as many problems, identified 3 times as many problems as the software engineer noticed in the user study evaluation. So one of the reasons that we want you to do 2 of them in this homework is so that you get a little more practice at observing what people are doing, looking for confusions, looking for barriers, and so forth. In a real situation, it's great to have the designers of the system, the engineers, and the management all watching. Another reason to have developers around, especially if you're testing the real system, is sometimes it'll crash or it'll get stuck. And as I said in the beginning, you're not really trying to find bugs, but if you do come across a bug, you have to know what to do about it. And sometimes maybe the engineer will have to come up and fix things. But of course, if you have the engineers in the room, they have some ego invested in the system. They know how everything works. You want to make sure they don't help too quickly. So my colleague Randy Pausch had a really cute strategy where he would make the engineers sit in the second row and sit on their hands. And they weren't allowed to jump up and try and help unless they said, I'm sorry I built such a sucky system. Here, let me show you what the problem is. And so that was a very effective strategy at keeping them back there watching in frustration as the subject is failing to succeed at the task that they thought was easy. Right? And obviously, at some point, like we said before, you're not learning anything new with having the user struggle some more. Right? At some points, any user is going to give up, or you already know you're going to fix that, and you know how to fix it, you just haven't gotten around to it yet. The user at this point would have given up and going to ask her son, how to do this step or whatever. So at that point, it does make sense to go and interfere or to help if you're not going to learn anything further. So that's one reason to have people there. But you really don't want to help too early because you know the answer, giving it the answer to the subject. And because the subject kind of knows that you know the answer, they're much more likely to keep asking you, okay, what do I do now? I don't see it right away. Where is it? And you keep having to say, well, pretend I wasn't here. What would you do then? Or why don't you see if you can figure out another way to try and do this? Yeah. So a usability lab is kind of a nice to have kind of thing. And many companies have them. We actually have 2 or 3 over upstairs in the HCI area, as well as one over on Craig Street. Typically, you have a room with the computer set up that you want to test with a bunch of cameras pointing at the user, pointing at the keyboard, pointing at the screen, pointing at the mouse, so that you can record all the things that happen. You might have a 2-way mirror. This glass here is actually, it's called 2-way, which makes no sense. It's actually 1-way. So the user inside only sees a mirror, whereas the users in the control room can see what's going on. And that way the subject doesn't actually get to see who's watching. And it's been shown that if you have an expensive setup like this, then companies will want to leverage their investment and they'll use it more often. Right? And so that's kind of one motivation to have one, is you'll do more user studies just because you happen to have this facility available. You might as well use it to do your studies. It's also really handy if you have a kind of elaborate setup. So you see in this situation, they have 5 monitors. And that would be kind of awkward to bring in and set up for somebody, right, if you wanted to test some really elaborate setup. So to the extent that you have something special you want to test that requires setup, it's much easier if you could just set it up once and leave it up, let people come in. But most of the time, it's perfectly reasonable to do this in a conference room or at the user's desk or at your desk or whatever, because most of the stuff that you're probably going to test is small. It's on a computer or laptop. It's on a phone or on a camera or whatever. So you don't really need a lot of special equipment. And nowadays, videotaping is trivial. You can set up your iPad or your phone or your laptop and just videotape things pretty easily. It's a little tricky if you want to videotape a smartphone screen, but there's little stands that you can get for a few dollars that can mount a camera pointing down at the screen, or you just make them put it on the desk and they mount a camera on a little tripod. So there's a lot of ways of doing this fairly cheaply and portably, so it's not really required. So if you don't have a usability lab, that's not an excuse not to do user studies. It's just kind of handy if you have one. So there are lots of stages in the evaluation, and surprisingly, there's a surprising amount of stuff that you need to do in each of the stages: preparation, introduction, running, and cleanup. So in terms of preparation, you obviously need to get everything set up before the user arrives. It's kind of embarrassing if the user arrives and you're not ready to go. So have the software ready, have it all set up. You want to give them some introduction to what the purpose is or what you want them to know about what you're doing. There'll typically be a consent form, especially if you're doing IRB, but many companies also have rules. So if you're doing this for a company, then you'll want to understand what their rules are about doing human subjects. And if they have any government contracts, then that'll have different rules. It turns out at CMU that studies you do as part of a class don't need prior permission, which is why we can just do stuff. Obviously, you should try to respect all of these kind of situations as well, but the IRB specifically is not invoked for class-based studies. If you have a pre-test questionnaire, you'll do that, and then the instructions. You'll want to specifically mention about think alouds if you're doing a think aloud, so that they know that they're supposed to talk and how that works, and you're going to keep interrupting them. You're going to then read from your script about what they're supposed to do. One of the other things is to try and emphasize that you wanted to kind of pretend like they were doing this on their own, or they would do this for real. And so they should kind of pretend that you're not there, although you keep interrupting them, so they're not going to forget that you're there. So you want to say that you're not going to be able to answer their questions once they get started, because the whole point is to see how well they would do on their own. So you should tell them that in advance so they're not surprised. And then you're going to try and emphasize that they should keep telling you what they're thinking. So an interesting thing about a lot of these studies, if you do a web-based study, then some of the links will be different colors because they're the ones that have been visited. And there'll be a history list that'll show where people have been, and maybe bookmarks. And all these fields will autofill based on the user's previous answers. And so there's all this kind of history stuff that you have to get rid of before the second user comes in, right? And so if you're doing a web-based study or a phone-based study or something like that, you have to figure out how you're going to clear out all the cookies, clear out all the history, reset everything, delete any files that were created during the study, so that the second user will get the same experience as the first user, and so forth. It may turn out that some of the stuff that the user created was interesting, and so then you have to not delete it, but move it somewhere else, try and capture it from the histories or something. And so what are you going to do with the information? Some of the data, you'll have times. You'll have numeric data, so you'll have times and number of errors. You can keep track of these in a spreadsheet or some other kind of numeric thing to look for interesting values. You'll look for trends and outliers, in terms of the data. For the usability problems, you're going to try and organize them by severity and scope. So scope means how widespread is this problem? Is it just on this one page, in this one input box, or does it really pervasive throughout our whole interface? Is it the overall architecture that we designed, or is it just this one prompt that needs to be fixed? Severity is how critical the problem is, and that's, high, medium, low is kind of the obvious levels, but it really kind of gets at the concept of did the user even notice this problem? Did they notice it, but were they able to overcome it? All the way up to this was such a big problem that the user got stuck and couldn't make any progress. They didn't know how to get out of this problem. And obviously, if they have situations where they're completely stuck, then that's a really high severity problem that they have to go ahead and solve. And you can put these kind of on a grid. So high severity problems that exist in many places obviously have to be fixed. And you might decide that high severity problems that are only in one or two places maybe aren't going to be as important. Things that are really low severity that are not many places maybe you won't fix. But maybe if something is everywhere, even though it's a small problem, because it exists in so many places, you might as well go ahead and fix these too, because lots of people are going to notice them all over the place rather than just occasionally. So the reports that we've set up, the first section is a brief description of the user. And remember, it's supposed to be anonymous, so don't use their real name. And just describe aspects of their demographic, skill level, why did you pick this person? And like the first assignment, you should pick somebody who doesn't really know how to do your thing, so you'll get some breakdowns. Then this section, anything you need to know about the context, where you're doing it, things like that. And then also the complete script. So you'll see that we keep asking you for the script over and over again. It's fine to keep using the same one if it still works for you. It's just a lot easier to grade if it's all in one place, right? So we don't have to go back to your homework 2 and try and find the script that you're using in homework 3. So just copy and paste the script into here is fine if it's the same one. Then there's a place for transcript. And I've turned on line numbering, so you can just type it into here and it'll just work automatically. So if you just type stuff, then the line numbers will work out automatically. Or you can add in time codes if you prefer. And then we get to this nice table. And this is a different way of presenting the information compared to the diagram. So the first column is the screen. You can plop it right in there if it's just a little picture. If it's a bigger picture, then you can put it somewhere else and circle the different parts. It's fine if you use the same picture for multiple problems. Just annotate where they are on the picture. Any reference is, description of where in the picture they should look. You could if you circle it and put a number 2, you could say at number 2, or you can say on the third button, or whatever is helpful. Then whatever happened, the reason why it happened, scope is, this page or all pages, severity and justification. So why do you think it's a low priority or high priority thing to fix? And then how to fix it. Okay, so, and also any trade-offs. So, if it's a typo, I spelled the name wrong and the user was confused, then there really aren't any trade-offs to fixing it. But if you have a command labeled something and you decide to label it something else, then it may interfere with a name you have somewhere else in your interface. Or if it used to be blue and you're going to change it to red, then it might interfere with people thinking it's an alarm or something because it's red. So that might be a trade-off. So we also provided an example. Nope, not that one. Maybe this one. So this is an example from the CDW situation. So here's the search page. I'm sure you remember that. And so the first one says it was at time code 110 on that picture, that there's a search box, but when the search was entered, then it failed. Why did it happen? Don't really know why the search failed, but they were added incorrectly. It only is relevant to the screen, but the severity is high because most people use search. And the fix is to have a better search mechanism. The trade-off is that it might return too many results, or obviously it's much harder to implement a good search than it is a bad search. All right, so that's just kind of an example. If what we saw before was wasn't a user study, and this is the other one about where I entered the doctor into the title field. So the user's informed he needs to enter a shipping address, and it didn't work. And it's only on this screen. It's medium because people will be annoyed if it didn't work. So it should be preserved. There's no downside to the user, but it does require more implementation effort. Right? So it's just a couple of examples to show how you would use this table. In real life, well, I think that's the end of that document. Is there something after that? Yeah. So in real life, you would probably have some sort of executive summary that you're giving up to your management or to the engineering team that says, here's the things that we discovered, here's the ones that are most important for you to fix. What you think about in terms of fixing them. The tricky part is to prioritize. In real life, you typically would come up with dozens of problems, and you have to use your judgment as a usability specialist to know which ones really need to be addressed. Often, it's very motivating to use some excerpts from your video in order to really communicate the depth of the problems. Obviously, you're going to modify your system, hopefully, to fix the problems. And as I mentioned before, it's perfectly reasonable to fix things if you are convinced that this is a real problem. You may say, I wonder if anybody else has the same problem. Let's postpone fixing it and see if we have the same problem with lots of people, especially for things that turn out to be hard to fix. So sometimes you'll want to fix them, sometimes you'll wait till later. Users will usually propose things. They'll say, it'd be so much better if you added this feature, or what I really want is this to be blue, or whatever. But you have to remember that the user's not a designer. So if they recommend fixes or changes, you don't necessarily have to take their word for it, right? And you don't have to necessarily base your redesign on their opinions. So this comes back to the difference between objectively having trouble with something and opinions about how to fix it or what would be different. So anything that they objectively have trouble with, that they actually fail at doing, that's a big sign that you should be fixing stuff. But if they're just giving you their opinions, or if they're helping you with redesigns, that's often useful, but it's not something you necessarily have to depend on. Okay. I wanted to also show you something I was looking for last time, but I couldn't find, which is this pretend website. And so this is from a previous class. They actually bought the URL, and it's still valid, so that's kind of fun. So this is from a class, and if you actually refresh the page, on the home page, I made them put it up. Because it's on the open web, I made them put a disclaimer on the front page that says that it was just a prototype, because it looks like a real website, right? But it's not. Okay, so this is more relevant to when you implement it for free. So if I type in, I forget what I'm supposed to type. If I typed in vitamins, it would look like it really worked well, right? Because I'd get this page with vitamins. But actually, I typed in aspirin, and I still got vitamins, right? So what's happening is the search button is hardwired to the URL search_result.html, right? And so it looks like there's a page full of search results. But they didn't require any implementation in terms of actually making a search engine or writing any code. They just hand designed this table. I notice also I'm on the second page of this table, apparently, because I'm seeing 20 through 27 of 1,001 results, right? And so if you gave this to your implementation team, they would very much be able to say, oh, yeah, I know how to implement this. I can see exactly what you're going for. This level of detail is perfect for being a specification, for testing users to see, suppose you were trying to see if they could find, this medicine or whatever, you would know that, or this vitamins, you could see if they could find it in this layout. And a lot of pages, like if I go to the FAQ, a lot of these pages go to this dead end page, right? I didn't implement this yet. And so if you're doing a user study and they get to this page, you would say, well, pretend this had a bunch of questions and answers, none of which were relevant to what you were trying to do. Or if one of them would be relevant, say, okay, pretend on this page there was the answer that the shipping would take 3 to 5 days no matter how much you paid. So you can, as the experimenter, pretend that you got to a page that actually had a result instead of this placeholder page. Another thing to note is that all of these buttons, all of these buttons are actually here, right? Even though he didn't implement them, right? If I was trying to see, can you figure out where this website would let you buy something, or how you would do search? If there's only 2 buttons on the page, the user is going to have no trouble figuring out which button to click on. And so one of the requirements that for the last assignment for the part C was that you have the complete interface in the same way that this looks like a complete interface, so that the user can be just as confused if your website is confusing or your interface is confusing, just as confused by your prototype as they would be by the real thing. Or just as clear, depending on how well you did. And there are even these links down here, none of which actually do anything, right? But they all look like real links. The cursor changes because they're real links. They all go to the same dead end page. So that's kind of the general idea. This one has a cart with 0 items, which when I go to it actually has 2 items, which kind of broken. I can log in, and I forget which name I'm pretending to log in, John Doe, right? And so again, all of these are just going to special pages. So this is the index page _login. And so they designed another page to look like I was logged in that had the same information just at the logged in page. So this is, if you remember the video of the paper prototype, again, there were all sorts of what you might call distractors. Parts of the interface that are not relevant to the task at hand that would be on the real interface in case the user, so that you can test whether the user understands the right way to go or not. Okay, I finished a little early. Any questions? Let's go back to the assignment for a minute then. So with respect to the schedule, so we're here. So next week, of course, we're going to have a lecture on Monday when the assignment's due, and then there's no class on Wednesday because of Thanksgiving. But unfortunately, there is a homework due the Monday after Thanksgiving. So if you want to have the whole holiday, you can do the next assignment on Monday and Tuesday. And the TAs have to work too because they have to grade your homework 3 during the holidays. And homework 3 is, all of these parts are in the template that we were going over, the script, the transcript, 5 rows of problems, the screens where they had the problem so that we can see what the problem was. And if you're interested in getting extra credit, you can do more users or lots more problems if you want, especially if you fix something. Then you'll try and fix the design and then turn in the second design. And then also be sure to have a summary of what changed so we don't have to go and try and fish around about it. And then finally, the template again. And this time we're only requiring you to find at least 2 problems. But you don't have to fix the problems you find in the second phase, because in the next homework we're going to implement that. Okay? All right. See you. Have a nice weekend. See you Monday.